Welcome back for another deep dive into
Several.
some really cool tech. Our listener is curious about E-Textiles,
Mm-hmm.
specifically how embroidery can be used to create circuits and connect to electronics.
Okay.
And you know me, I'm always up for a challenge.
Right.
So they sent over a research paper.
Mm-hmm.
It was originally published in German.
Oh, wow.
Yeah.
Interesting. So
We're gonna kind of unpack it
yeah, unpack it.
and figure out how to get those tiny stitches
Yeah.
to conduct electricity reliably, especially after going through the wash.
Yeah, that was a big question that I had. Like,
Mhm.
how many times can you wash this before it falls apart?
Exactly.
So we'll
Yeah.
look at the different types of conductive threads that were tested in the research, including those made from silver-coated nylon and even stainless steel filaments.
Stainless steel.
I know.
That's wild.
I was surprised
Yeah.
when I saw that.
Yeah.
That's pretty cool.
We'll also learn about the really amazing experiments
The experiments.
they conducted
Yes.
to discover the best embroidery techniques for creating these really durable electrical connections.
Yeah, they
Yeah.
really went deep on this.
Okay, so before we get too far, can we just define some terms?
Sure.
What are smart textiles and e-textiles?
Yeah, so the paper actually defines a smart textile as any fabric that can interact with its environment,
Okay.
like reacting to temperature changes.
Okay.
And e-textile takes it a step further
Mm-hmm.
by integrating electronics
Okay.
to control or manage that interaction.
So there's levels of integration.
Exactly.
Like you could have a regular piece of fabric
Right.
and just stick a device to it.
Yeah.
That's-
Or you can integrate electronics
Yeah.
more closely into the fabric itself. But this research
Mhm.
focuses on
The most.
the most integrated level
Yeah.
where the fabric is the electronic component.
Yeah. That's what I thought was so cool
Yeah.
about this research.
Yeah.
That's what they're focusing on.
Exactly.
So that's where embroidery comes in.
Right.
And they highlight how embroidery is really well suited for e-textiles
Mm-hmm.
because it offers this amazing combination of lightweight flexibility,
Yes.
precision, and the ability to create 3D structures.
Yes. You can't get that same level of detail
Right.
with other textile techniques like weaving or knitting.
That makes sense.
Yeah.
When you think about it,
Yeah.
I can see how the precision
Yeah.
of embroidery
Precision is,
is crucial for creating those tiny circuits.
Yeah.
So I'm curious, how does embroidery actually work? I'm picturing
Yeah.
these old school sewing machines.
Yeah. With a foot pedal.
Yeah, how
Right.
does that actually work?
So modern embroidery machines use a really sophisticated needle hook system to create the stitches.
Okay,
It's kind of like a choreographed dance
Wow.
between the upper thread and the lower thread,
interesting.
with the needle moving up and down
Yeah.
through the fabric and a hook underneath catching the thread
Huh?
and forming the stitch.
Oh, okay.
The specific type of stitch used in this research
Yeah.
is called a double lock stitch,
Oh, okay.
which is known for its strength and durability.
So they're not messing around with just a basic running stitch.
No, they're not.
Okay.
This is high-tech embroidery.
Yeah, this is the real deal.
Yeah.
But even with these really strong stitches,
Mm-hmm.
I imagine connecting those embroidered circuits
Yeah.
to actual electronic components poses a big challenge.
It does.
Yeah.
The research actually goes through a range of existing methods, from gluing and soldering to more specialized techniques like welding and crimping.
Wow.
But each method has its drawbacks.
Okay.
Gluing can be messy and less durable.
Makes sense.
Soldering requires heat, which can damage delicate fabrics.
Right.
Embroidery offers mechanical strength, but achieving consistently low electrical resistance,
Which is
key
important.
for a reliable connection,
Right.
is the real hurdle.
Okay, so what's the solution?
Well,
How do they get around that?
this research uses embroidery for both creating the conductive paths
Wow.
and connecting them to the electronic components.
Okay, so they're really pushing the boundaries
We are,
of what embroidery can do.
yes.
Oh.
And to add to the complexity,
Mm.
they're using a specialized electronic board
Okay.
designed specifically for embroidery
Okay.
called the ZSK E-Tex board.
Wow, so it's like building a bridge between
Right,
a traditional craft world
Uh-huh.
and cutting-edge technology.
Yeah.
That's really cool.
It is.
What are these conductive threads actually made of?
Okay,
If I doubt it's your grandma's embroidery floss.
you are right. They're not.
Okay.
They test in 4 different types of conductive threads in this research.
Okay.
3 of them are silver-coated,
Yep.
Madeira HC40.
Which is made of silver-plated polyamide filaments, and 2 from Amon, Silvertech Plus, and Silvertech, which are multi-filament yarns
Mm-hmm.
with a silver coating.
Okay.
The plus version
Yeah.
is just a coarser yarn compared to the regular silver tack.
So silver threads.
Yeah, literally.
Literally.
That's kind of cool.
Yeah, it's pretty cool.
Yeah.
But why silver?
Well,
Is it just because it's shiny?
it is shiny,
Yeah.
but silver is an excellent conductor of electricity.
Okay.
It's actually the most conductive metal.
Oh, wow. I didn't know that.
But there's a fourth thread
Okay.
they tested
Okay.
that breaks the mold.
Okay.
Amon steel tack.
Okay.
It's a mix of stainless steel.
Stainless steel thread.
Yes.
That's amazing.
And polyester filaments.
Is it like stiff and scratchy?
It can be.
Ah.
The research mentions that stainless steel, while highly conductive, can be brittle and tricky to work with.
Oh, compared to the more pliable silver-coated threads.
So there's trade-offs
There are.
to consider
Yeah.
high conductivity versus...
It's ease of use.
Yeah.
Okay.
Okay. It makes me wonder which thread performed the best.
Right.
But before we get into that,
Okay.
I want to understand how they actually tested these threads.
Sure.
They weren't just making, like, pretty embroidery patterns.
No, they weren't.
Okay.
The experiment was all about finding the optimal embroidery parameters
Okay.
to create the most reliable electrical connection to that specialized ZSK E-Tex board.
Yeah, the one you were talking about.
Yeah.
What kind of parameters did they test?
They looked at 3 key factors.
Okay.
Stitch length,
Okay.
the arrangement of the stitches, whether they were parallel or crossed,
Okay.
and the number of stitches used to make the connection to the board.
Okay.
And they didn't just test a few samples.
Right.
They created 80 samples for each thread, with varying parameters totaling 320 samples.
320 samples.
Yes.
It's amazing.
And then to really put them through the ringer,
Mm-hmm.
they subjected all those samples to 50 wash cycles.
50 washes.
Yes,
That's serious commitment.
it is.
How do you even measure whether a tiny stitch is conducting electricity properly?
Well, they used a multimeter to measure
Yeah.
what's called electrical contact resistance,
Okay.
which basically tells you how much the connection resists the flow of electricity.
Uh-huh.
The lower the resistance, the
Yeah.
better the connection.
So after all of that stitching and washing and measuring,
Yeah.
what did they discover?
The results were very intriguing.
Okay.
All 3 silver-coated threads, Madeira HC40,
Mm-hmm.
Amon Silvertech Plus,
Yeah.
and Silvertech,
Okay.
showed consistently low contact resistance even after 50 washes.
So silver really proved its worth
It
in
did.
terms of reliability.
Yes.
The Amon steel tech.
Yes.
Yes.
Started off strong with low resistance, but became less reliable over time.
With frequent connection failures.
So silver's in the lead,
Yeah.
but stainless steel,
Might still have some potential.
yeah, maybe with some tweaking.
With some tweaking.
Okay.
Mm-hmm.
What about the other parameters they tested?
Right.
Like stitch length and the arrangement of the stitches?
Yeah, did those make a difference? They did.
Okay.
And this is where the research gets really interesting. One of the most surprising findings was that shorter stitch lengths consistently led to better conductivity
Really?
and fewer failures.
So shorter stitches are stronger.
But it turns out that longer stitches are more prone to damage
Okay.
from the friction and agitation of washing.
Oh, okay.
They can get snagged,
Uh-huh.
stretched,
That's right.
or even break,
Yeah.
leading to increased resistance
Okay.
and eventual failure.
So it's all about finding that sweet spot.
Between making contact
Right.
and minimizing the risk of damage.
Yep. Exactly.
It seems counterintuitive.
It does.
But I guess that's why they do the research, right?
Right. Exactly.
What about the crisscross versus parallel stitch thing?
So the research dives deep into each thread and the specific parameters,
Okay.
and we'll definitely get into those details.
Okay.
But before we do, I think it's important to step back and appreciate what this research really tells us.
Okay.
You know?
So let's get back to those specifics.
Okay.
You mentioned that the research looked at each thread in detail.
Yeah.
What did they find out about the best way to embroider those connections?
Well, the most consistent finding across all the threads
Mm-hmm.
was the importance of stitch length.
Okay.
Shorter stitches really proved their worth,
Yeah.
especially when it came to durability after repeated washings.
But what about those other parameters, like the
Right.
stitch arrangement
Mm.
and the number of stitches?
Yeah. Did those have a significant impact?
Yeah.
They did.
Okay.
But the effects varied depending on the thread.
Well,
For example, with the Madeira HC40,
hmm.
the silver-plated polyamide thread, the stitch arrangement didn't seem to matter much.
Okay.
Parallel and crisscrossed stitches performed equally well,
Okay.
but the number of stitches did have a slight impact.
Okay.
Initially, 5 stitches showed slightly higher resistance, but over time they actually performed a bit better than 3 stitches.
So with the Madeira HC40,
Yeah.
it's mainly about keeping those stitches short,
Right.
and the rest is pretty much up to the designer.
Pretty much.
Okay.
But with the Amman Silver Tech Plus thread,
Mm-hmm.
the coarser of the 2 silver-coated yarns, the number of stitches played a more significant role.
Okay.
Using 5 stitches created a much more reliable connection than 3,
Okay.
especially with longer stitch length. The microscopic analysis showed that the combination of longer stitches and fewer stitches sometimes caused the silver coating to flake off during washing,
Oh.
leading to connection failures.
Interesting. So it seems like with a thicker yarn,
Yeah.
those extra stitches provide more surface area
Right.
for contact,
Yeah.
which helps maintain a stronger, more consistent connection.
Exactly.
What about the finer Amman Silvertech thread?
Right.
Did it follow the same pattern?
Not exactly.
Yeah.
While shorter stitch lengths still resulted in lower resistance overall, using 5 stitches instead of 3 had a more dramatic impact on the connection's reliability with this finer thread.
Okay.
It seems like those extra contact points were crucial for maintaining conductivity.
So for the finer Silvertech thread,
Yeah.
more is definitely more
More is more.
when it comes to the number of stitches.
Yeah.
Okay, so we've covered the silver-coated threads.
Right.
What about our rebellious friend, the Amman Steel Tech?
Yeah. Did it manage to redeem itself?
Yeah.
Unfortunately, that stainless steel thread's brittleness continued to be a problem.
Oh, okay.
Many of the Steel Tech samples, particularly those with longer stitches, experienced connection failures during the wash tests.
Oh, yeah.
Imagine those tiny stainless steel filaments snapping
Oh.
under the stress of all that tumbling.
Yeah, that doesn't sound good for the fabric either.
No,
So it's back to the drawing board for stainless steel.
not necessarily.
Okay.
The Steel Tech samples with 5 crisscrossed stitches did show some promise.
Oh,
They maintained relatively low resistance, even though they did have some connection failures. So there might be a way to optimize the embroidery parameters or even modify the thread itself to make stainless steel a viable option for E-Textiles.
So it's not entirely out of the running.
Not entirely.
But for now, it seems like those silver-coated threads are the clear winners
Yes.
in terms of reliability. You know, we've been focusing a lot on the technical details of the research.
Right.
But I'm curious to hear your thoughts on the bigger picture.
Sure.
What are the implications of these findings for the future of E-Textiles?
Well, I think this research is incredibly valuable because it provides designers and manufacturers with practical guidelines for creating e-textiles that are not only functional but also durable enough to withstand the rigors of everyday life.
Exactly.
We're talking about smart clothes that can go through the wash without falling apart.
Literally.
Literally.
That's what I want.
Yes.
I want to be able to wash my clothes and not worry about it.
Exactly.
This is a big step towards making E-Textiles more mainstream and accessible.
It is.
I'm all for a future
where
our clothes can do more than just look good.
Right.
But I think there's also a certain beauty in the fact that this research is using a traditional craft like embroidery to push the boundaries of technology. It's like a fusion of art and science.
It is a reminder that innovation can come from unexpected places. We often think of technology as being all about sleek gadgets and complex algorithms. But sometimes the most elegant solutions are found in the simplest of things, like a needle and thread.
Absolutely. And I think that's what makes this research so fascinating. It's not just about the technical achievements. It's about the potential to blend the old and the new, the handmade and the digital, to create something truly unique and innovative.
Precisely. It's about finding those connections between seemingly disparate worlds and exploring the possibilities that emerge.
And this research is really just scratching the surface.
It is.
There's so many directions this field could go in. So many potential applications yet to be discovered.
I know.
That's what I find so exciting.
Me too.
It's like we're standing at the edge of uncharted territory. And this research is like a map guiding us towards a future where e-textiles are integrated seamlessly into our lives. But before we get too carried away with future visions, let's bring it back to the research itself. What are some of the key takeaways that stood out to you?
You know what I found most remarkable was the unexpected finding about stitch length.
Yeah.
It really highlights the importance of understanding the materials and processes involved in e-textile creation.
Right.
Even seemingly minor details can have a major impact on the functionality and durability of the final product.
Yeah, it's like a reminder that even in the world of high-tech innovation, the fundamentals still matter.
They do.
Sometimes the simplest solutions are the most effective.
Exactly. And it also underscores the need for rigorous testing and analysis.
Yeah.
You know, this research involved meticulous experimentation, microscopic analysis, and statistical evaluation to arrive at its conclusions. It's a testament to the power of scientific inquiry.
Yeah.
But even with such thorough research, there are always more questions to explore.
That's true. It's like every answer unlocks a dozen new questions.
It does.
What are some of the areas that you think warrant further investigation?
Well, for starters, the research focused on connecting embroidered circuits to a specific electronic board.
Okay.
I'd be curious to see how these findings translate to creating more complex circuits, integrating multiple components, or even developing entirely textile-based electronic systems.
That opens up a whole new realm of possibilities.
It does.
Imagine clothing that can not only sense and react, but also process information and make decisions.
Right.
It's like taking wearable technology to a whole new level.
Exactly. And then there's the question of scalability.
Right.
How do we move from lab-scale experiments to mass production of e-textiles?
Yeah.
What are the manufacturing challenges, and how can we make these technologies more cost-effective and accessible to a wider audience?
That's a crucial point.
It is.
It's one thing to create a prototype in a lab.
Right.
But it's a whole other challenge to bring it to market at a price point that people can afford.
Absolutely. And of course, we can't overlook the environmental considerations.
Right.
As with any emerging technology, we need to think carefully about the sustainability and recyclability of e-textiles.
Yeah.
How do we minimize waste and ensure that these materials don't end up polluting our planet?
Those are important questions.
Yeah.
It's exciting to think about the potential of e-textiles.
Yeah.
But we also need to be mindful of the potential downsides.
Right.
And work towards creating solutions that are both innovative and responsible.
Absolutely.
Yeah, it seems like with any technological advancement, there's a balance to strike between the excitement of what's possible and the responsibility of considering the wider implications.
Definitely. But those challenges are also what make this field so compelling.
Right.
There's a real opportunity to shape the development of e-textiles in a way that benefits both people and the planet.
It's like we're not just observers of this technology.
Yeah.
We're active participants in shaping its future.
Exactly.
And speaking of shaping the future, this research, being originally published in German, got me thinking. It makes you realize how much knowledge is out there, waiting to be translated and shared across borders.
Absolutely. Science and innovation are global endeavors. We need to keep those channels of communication open and ensure that discoveries and advancements, no matter where they originate, can benefit everyone.
Well said. Now let's have some fun.
Okay.
You got me thinking about all the possibilities of e-textiles.
Right.
If you could design any smart garment, what would it be?
Ooh, that's a tough one. So many ideas swirling around.
Yeah.
I think I'd go for a jacket that could adapt to different environments.
Okay.
Imagine a jacket that senses changes in temperature or humidity and automatically adjusts its insulation or breathability.
Oh, that's nice.
You'd be comfortable no matter the weather.
I'm feeling cozier just thinking about it.
Right.
No more bulky layers.
Or that awkward dance of putting on and taking off clothes as the weather changes.
Exactly. Or for athletes, how about a shirt that monitors muscle fatigue?
Okay.
Or provides real-time feedback on form to prevent injuries and improve performance.
Now I'm imagining a sports bra that tells you to stand up straighter.
Huh.
Helpful, maybe, but also potentially annoying.
We definitely need to fine-tune the personality of those e-textile coaches.
Yeah.
But on a more serious note, the potential in healthcare is huge. Imagine bandages that detect infections or clothing that helps regulate body temperature for people with certain medical conditions.
It's amazing to think that we could create these life-changing applications using something as simple as embroidery.
I know.
It really highlights the ingenuity of combining traditional crafts with cutting-edge technology.
It really does, and it makes you wonder what other seemingly ordinary things might hold extraordinary potential in the digital age.
Yeah.
What other crafts or techniques could be reimagined and transformed?
That's a fantastic question to ponder.
Yeah. What hidden gems are we overlooking?
Right.
Maybe it's time to dust off those knitting needles or fire up the pottery wheel. Who knows what e-textile wonders are waiting to be discovered?
I love that image.
Yeah.
There's a whole world of possibilities out there just waiting for us to unravel them.
Yeah.
It's a reminder to stay curious, keep exploring, and never underestimate the power of a good idea no matter where it comes from.
Well said. And on that note, I think it's time to wrap up this deep dive into the world of e-textiles.
Okay.
It's been an illuminating journey.
It has.
Thanks for joining us, and we'll catch you next time for another fascinating exploration.
Sounds good.